All right, so we're going to continue our lesson on transformations. We're going to start by graphing a familiar function, the parent function, y equals x squared. At this point, hopefully you've getting pretty close to just memorizing these 5 points for the quadratic. And of course, this quadratic should be a U-shaped graph. And now we're going to graph this transformation. And for right now, we're going to go and pick just the same x values we always pick. And what we're going to do with this function is we're going to add 3 to each one of the x values and then square it. So that first x value is -2 plus 3, and we're going to square it. And that gives us 1. And just go right on down the list. The next x value is -1 plus 3, and we're going to square it. All right, and then there are the rest of the values you get from the t-chart. You notice you get some pretty large values, probably to the point where you thought maybe you made a mistake. But we're going to go ahead and graph as many of those points as we possibly can. So the first point is the point -2, 1. Remember, this bottom row is the same thing as y, f of x. So -2, 1, -1, 4, and really 0, 9 is the last point we can comfortably fit on this graph. 116 is way, way, way up here off the graph. So you'll notice what we've got here is basically we've got the right side of this parabola, of this U-shaped graph. And you'll also notice that how these 2 points are kind of lining up horizontally and these 2 points are lining up horizontally. And how much of a shift is that? That is a shift of 3 units, it looks like, to the left there. Now I'm going to go and erase that part in the yellow, but I just wanted to throw that out there. So what that tells me is we need to pick some different values here. So go ahead and erase those values that were too big to graph. And we know that the rest of this graph is probably going to look something like this. So we need to pick x values that are to the left of -2. So I'm going to pick an x value like -3 and -4 for x. And normally, of course, yeah, we'd want them to be over here on this side of the t-chart, but we don't really have space. So let's substitute -3 in for x and -4 for x. -3 plus 3 is 0. 0 squared is 0. -4 plus 3 is -1. Squared is 1. So now we can go and graph those points. And -3, 0 is the key point, because you'll see that's the vertex. And if we want to, we can go even one further. We can go to -5 for x and plug that in, and we get 4 for y. A little lopsided, but you can kind of see now how this graph has shifted. Each one of those points, especially the vertex, kind of the key point, is a shift left 3. So when they say describe the transformation, we're going to say shift left 3. Then I'm also going to say shift the parent function left 3. So that may be backwards of what you were thinking. Vertical shifts are pretty straightforward. Horizontal shifts, when it's on the inside, kind of does backwards of what you might think. That +3 is actually shifting us left 3 ordered. Or I should say shift the x value left 3. So again, you kind of have to think backwards on these. So you notice right here, negative 5, 4. If we add 3 to negative 5, we would get 2, 4. So we're really adding 3 to the end result to kind of go backwards and get the parent function. It's a little confusing at first, but I can guarantee you'll get used to it. So we're going to graph the following functions on the same graph. So we got one big graph to graph all 3 of these functions. It's the square root function, one we haven't dealt with much. But remember, when we pick values for the x value, we don't want to pick -2, -1, because you can't take the square root of a negative number. So instead, we're going to take 0, we're going to take 1, we're going to take 4, and we're going to take 9. And we don't really want to do anything past that because it gets difficult to graph. So when we take the square root of 0, we get 0. We take the square root of 1, we get 1. The square root of 4 is 2. The square root of 9 is 3. Again, that is the familiar parent function. And for right now, I don't think I'm going to connect the dots, just because we're graphing 3 functions here. But I'm going to do it in a different color, and you might do it in a different colored pen or do it really light colored since this is the parent. So we're going to pick the same x values, 0, 1, 4, 9 for this next one. You'll notice this next one, think about what type of shift this should be. You've got a +3 on the outside. So when it's on the outside, it tends to be a vertical shift. Now we can check this. If you take the square root of 0, you get 0, and then you add 3 to it, you get 3. So we're really just adding 3 to these parent function values. Square root of 1 is 1, plus 3 is 4, the square root of 4 is 2, plus 3 is 5, the square root of 9 is 3, plus 3 is 6. So go ahead and graph those points. So you notice all of those new points in red are a vertical shift of 3 from the parent. Here pretty soon we're not going to have to use the table of values. We can just use these shift rules to kind of use as shortcuts to graph some of these transformations. All right, so this last one, and this is the tricky one. We've got a -1 on the inside. So that, think about where that's going to shift us. A -1 on the inside is actually going to shift us right 1. So when we're picking our x values, we want to add 1 to every single one of these normal x values that we pick up here. So instead of 0, 1, 4, 9, we're going to pick 1, we're going to pick 2, we're going to pick 5, we're going to pick 10. And now we're going to substitute those in to this function. So we're going to take that first x value. It's going to be 1 minus 1. 1 minus 1 is 0. The square root of 0 is 0. So here are the ordered pairs that you should end up getting when you plug in 1, 2, 5, and 10 for x. Go ahead and graph those. And I'm going to go ahead and graph the transformations, but I'm going to leave the parent alone just because it's kind of messy in there. So you'll notice the blue function, we shifted right 1 from the parent. the plus 3 on the outside, we shifted up 3. So finally, the transformation rules for absolute value, quadratic, and square root functions. So all these functions kind of share the same format. Notice how k is on the outside. So if k is positive, you shift up. If k is negative, you shift down. And I kind of have this side note. If the number is on the outside after the function, then you're going to do the obvious vertical shift. And what I mean by obvious vertical shift is if it's a plus 2 on the outside, well, your brain immediately goes to, okay, a plus 2 means up 2. A minus 2 we think is bad. We think as moving downward. So that's what I mean by obvious vertical shift. And if h is negative, you're going to shift right h units. If h is positive, you're going to shift left h units. This is the tricky one. The number on the inside does a horizontal shift, but it's basically backwards of what you might think. And that's because if you look at the formula, there's already a minus sign in the formula right here. So if you insert a negative into the formula, it's going to make it positive. Pause the video if you need to. The last thing we're going to do is I want you to try these. I want you to determine what type of shift of the parent has occurred with these 8 questions. I'm going to go over some of the answers, but if you want to, pause the video in about 5 seconds. I'm going to go over the first 4 answers. All right, so here's the first few answers. A plus 2 on the outside means up 2. A minus 1 on the inside, that's the tricky one. You think maybe that means left, but it actually means right 1 of the parent. Number 2 is a down 5, minus 5 is on the outside, plus 10 on the inside, that's a left 10. Number 3 is a tricky one. So there's no parentheses, so you don't really see an inside or outside, but there's an assumed parentheses around the x, since that is what you are squaring in this problem. Like number 1, you were squaring all of x minus 1. On number 3, you were only squaring one term, so they don't feel the need to put parentheses, but the parentheses are there, so that 3 is on the outside. And then number 4, finally, that minus 1 is on the inside, so it's a horizontal shift, so it's going to go right 1. Try the last 5, and I'm going to flash the answers up here in just about 5 seconds. All right, so there's the last few answers, and you notice, of course, these right here are the answers. This is just kind of the cheat sheet over here. If it's on the outside, it's a vertical shift. It's on the inside, it's a horizontal shift.